Okay, today we are going to be starting into chapter 10. Just like any of the other chapters, when we start with a new concept, we are going to talk a lot about the vocabulary and the notation in relation to that concept to make sure we're all on the same page and that we understand it correctly. So our learning target for today, students will be able to identify and name parts of a circle using correct notation. So that correct notation is going to be really important for you to understand moving forward. And then calculate lengths using tangent properties. So we'll talk about what tangent means, not related to our triangles. So first of all, the definition of a circle is given as the set of all points in a plane that are equidistant from a given point called the center. So you can see in the diagram to the right, there's a center, and that point right there is equidistant from all the points on the outside. Naming a circle, we use the symbol that's shown right here. It just looks like a mini circle, and we follow it by whatever the center's label is. So for example, in this diagram right here, we have circle B. So we would name it as circle B, and we would read it as circle B. Now, the diagram off to the right, this larger circle, again, if we were to name this one, we would name it circle A, because its center is named A. So that's how we will distinguish between the different circles that are given. Now the other parts of a circle are lines and segments moving through the circle. These lines and segments will often intersect, creating angles. We will talk about angles more so next time. But today we just want to make sure that we can recognize and identify the parts of these circles correctly. So first of all, we need to understand that some are segments and some are lines. Now remember, segments have endpoints. So they go from here to here, and we generally will label the ends of those segments as points, and we name them based off of that. If this was X and this was Y, then we would call that a segment XY. We would write X and Y next to each other and put a little segment line over the top. Now, if it's a line, that means it's infinite. It's going forever in both directions. Again, you do need to have at least one point on the line. So if this was D, we could call that line D. Or if there were 2 points on here, but we're talking about not just D to E, but the entire line, then we would write D, E with a line over the top. Okay, so let's talk about these parts of the circle. Some of them should be familiar. Others may not be. Again, let's just make sure that our notation is correct. And we'll see if I can draw some straight lines. First of all, the radius. The radius, again, this is a straight segment connecting the center to any point on the circle. So a radius starts at the middle and it radiates out to the circle. So that right there would be a radius. And we could name this, let's say that's B. So if I wanted to write radius AB or show that this was the radius, I would say A to B. And again, that's a segment. It ends at B, starts at A, so we would write it as AB. Now for the radius, we often use a lowercase r, so you'll often see just the radius written as lowercase r when we're calculating with formulas and other things like that in relation to circles. A chord is a straight segment whose endpoints both lie on the circle. So a chord could be something where its first endpoint is here, it comes through the circle, and then the other endpoint is right here. We could call this point C, we could call this one up here D. That is a chord. Sorry, it doesn't look quite straight, but C to D would be a chord. Now again, there could be so many different chords in here. We could have one that goes right here. We could have one that goes right here. We could have one that goes right here. As long as those endpoints lie on the circle, that creates a sort of chord. Okay. So for example, if I wanted to write this one with correct notation, I would write C to D, and that again is a segment. It is not going forever in both directions. Now a diameter is just a special type of chord. So this is a chord that passes through the circle. So you guys are probably more familiar with the diameter. But again, if I were to draw a point here, and this one might be a little trickier, going through the center, crushed it. This would be a point here and a point here, that's an F. And that would be a specific type of chord. We call it a diameter because it goes through the center of the circle. So now notice our diameter we could write as FE, and that again is a segment. Now notice when I created the diameter, I actually created two more radius pieces. So if I wanted to look at, and I will erase this, but A to F, notice there's another radius. So if I were to ask to identify 3 radius pieces on this circle, E to A would be one up here at the top from E to A. Another would be from A to F. And then that third one that we already looked at, A to B, would also be there. So any of those would be related to radius. I'm going to undo all that so it doesn't get confusing. Okay, the last 3 are maybe more new. The secant line, this is a line that passes through and intersects the circle at 2 points. So again, this one is a line. It's going to just pass right through the circle. I'm going to use red just so maybe it looks less confusing. But again, it's just going to cut right through the circle. Pretend that's a straight line. And we often name that one also related to points on the line. So sometimes the points will be right on the circle, and maybe this is M. Sometimes they will be off and they're just sitting on the line. This could be N. You can have as many points as you would like on a circle, a line. However, it just depends which parts of the line that we're talking about when we name specifically. So if we were looking at this one, again, you can use any of those 3 letters to name this line. The secant line could be N, M, and then we would put a line over the top. Now again, just like I created more radiuses when I created the diameter, notice you also created another chord there. So if we were to move from P over to M, and I were to write that like this, that's a chord. That's a piece of the secant line that's creating, or whose endpoints lie on the circle. So just recognize we create different parts as we continue to draw lines through this circle. The last one is a tangent line. Tangent lines, what they do is they touch the circle once. So it's a line that touches the circle once, creates a 90-degree angle with the radius that it's next to. So for example, if I were to create, it's a little harder to draw, but a tangent line off to the side here, yikes, pretend it's touching right there once. This would be a tangent line. Okay, I'm sorry, I have to try again. Okay, it's getting worse. The tangent line, again, just touches the circle once at what we call the point of tangency. So if mine is touching right there, which, it's pretty close, that would be my point of tangency, where it touches. So if I were to name this, that one's already named B. Let's say I give a point on this line, and let's call this, what haven't I used, T. That tangent line, if I come over here to name it, would be tangent line BT. And again, this one's a line. It's going forever in both directions. And that point of tangency, or where it touches the circle, is point B. Again, that one's a point, so I'm not putting a segment or a line over the top. Relating to tangent lines, we're going to look at some different types of tangents, what we call common tangents when we put more than one circle in a plane. So I'm going to go through these rather quickly. Hopefully this will make sense. First of all, what is a common tangent? This is a tangent that's going to touch 2 circles, so it's going to be common to both circles. And when we're looking at this, it's just important that our circles, if they are going to touch and have a common tangent, that they are coplanar. Okay, and coplanar means in the same plane. If you think about maybe the wheels on your bike, they have gears that move those wheels, and those gears have a chain that connects the 2 of them. They have this tangent that is touching the tops or the bottoms, and they wrap around them. But if you think about those that are connected, they're in the same plane. If you were to move those gears away from each other, then that chain can't connect to them and continue to rotate. So coplanar means within the same plane. So we can have different types of coplanar circles. Some of them don't have intersections. So if we were to look at a couple of those, that would be like circles that aren't touching. So they never intersect, they're just in the same plane. Sometimes you'll have a circle within another circle, so this would be another situation right there. Now if the circles, so let's say we have one on the outside, we have one on the inside, okay, and they share the same center, so those are different sizes, they have different radius lengths. We call these ones concentric circles, again, if they share the same center. Sorry, that's very small. Hopefully you can read it. One intersection just means that the circles are touching. So if they're going to have one intersection, they're going to just touch. Okay, those are circles. And you could have one inside the other one as long as it's just touching once, like right there. Okay, that's rough. Two intersections, again, if the circles are overlapping, like our Venn diagrams, it's going to create two intersections, so that's what it would look like. So again, a common internal tangent, what does that mean? Well, if the tangent has to be common to both, an internal tangent means I have two circles here, and again, they can be next to each other or touching or not. But if I have these circles right here, and let's say I were to draw an invisible line, but mine's not going to be invisible, from their centers, if the tangent cuts through those two, or cuts through that line, then it's an internal tangent. So notice if I touch this circle and touch this one, yikes, that's an internal tangent. It could go that direction, or you could have one coming the other direction as well. So notice this one. Okay, that's not going to touch. If I have one, okay, coming this direction, well, I tried. It's going to touch here and here. Okay. Common external tangent, so if we're looking at that one, now again we've got two circles. They could be the same size, not the same size. This one does not pass through that little connecting center line. This one's on the outside, just like it sounds like. So external would be one that's coming across the top. This is again more like your bike chains where it's moving both gears in the same direction if it were to connect and rotate, but you could have one here and you could have one here. So notice there are two external and two internal here. So I'm going to quickly go through these examples. Notice on this first one, there are no common tangents. There is no way for me to draw a line that touches that inside circle that won't touch the outside circle only once. So if I was asking how many common tangents here, there would be none. There is no shared common tangents. I'm going to skip this example below and move to this one over here. Notice this one will have one common tangent, just this guy right here. So this one would have one common tangent. There again is no way for me to draw any other common tangents through the inside here without touching the other one more. And then this last one right here, it looks like we could have one here and here. Oh man, I'm sorry. I thought the whiteboard was hard. This thing's tricky. Notice here and here. So these two right here, these are external tangent lines, and then I could also draw my two internal tangent lines. So this one right here could actually have four. Now again, as long as you're only touching each circle once, you've come up with a common tangent. This bottom example, again, I'm not going to finish all the way through it, but if I was just talking about this large circle and the small circle, I could draw an internal tangent that goes right here. It will only touch each of them once if they are only touching at one point. This circle right here kind of throws things off because there's no way for us to create a common tangent between all three of those. So that's tangents and naming parts of a circle. So the first part of your assignment, you're going to practice with using the correct notation and identifying different tangents of a circle. If you print the assignment, those common tangent pieces are already on there. The circles are drawn. If not, you're going to need to copy them as best you can from the textbook.